Question 1. The diagram shows the energy profile for a catalyzed and uncatalyzed reaction, which represents the enthalpy change. Okay, we're looking for the enthalpy change and the activation energy for the catalyzed reaction. So the enthalpy change will simply be the difference between that point and that point, which is Z, and the activation energy will be this here, so that's Z plus X, which is A. 2. Excess magnesium powder was added to a beaker containing hydrochloric acid. The mass of the beaker and its contents were recorded and plotted against time, which could give line 2. So in line 2, we have the line decreasing more rapidly. So the mass is decreasing more rapidly. And also the mass at the end is much lower. So what could give us that? Doubling the mass of powdered magnesium? No, that would give us the opposite. Using the same mass? No. Increasing the temperature? That might help with this bit there, but not here. So it's not C. Using the same volume of more concentrated hydrochloric acid? Yes. Three, copper catalyzes the reaction between zinc and dilute sulfuric acid. Why does copper affect the reaction? It decreases the activation energy. Yes, it does. Yeah. It doesn't increase it. It doesn't do anything to the enthalpy change. It's a catalyst, which means it's not used up in the reaction, but it does decrease the activation energy. 4, 100 centimeters cubed of 10% hydrogen peroxide solution decomposes. It forms water and oxygen. The dotted line represents the volume of oxygen produced. Which graph represents the decomposition of an equal volume of a 20% solution? Okay, so we've got more of the hydrogen peroxide. More of it. It's more concentrated, which means we'll get a lot more gas here. Even though it's the same volume, because it's more concentrated, we can't be ending up at the same point. So it won't be B or C. D is even lower, so that's out, which leaves us with A, 4A. 5, which change does not increase the initial rate of reaction when calcium carbonate is added to hydrochloric acid? Which change does not increase? Okay, decreasing in the size of the particles, yeah, that would increase. Increasing the temperature, again, that would increase the initial rate. Increasing the concentration of hydrochloric acid, nope. Increasing the volume of hydrochloric acid and keeping the same concentration, yes. The initial rate is not affected by volume increases, but rather concentration changes. 6, which methods can be used to monitor the progress of this reaction? Change in color, yeah. Change in mass, change in volume, yeah. So that will be D. 7, the rate expression for the reaction is: by which factor will the rate of reaction increase when the concentrations of X and Y are both increased by a factor of 3? So this calls for us to replace X and Y with the factor, so 3. We have 3 to the power of 0. Well, that'll be 0. And we also have 3 to the power of 2, which is 9. So obviously that will be 9. B. Which pair of statements explains the increase in rate of reaction when the temperature is increased or a catalyst is added? Well, we've just talked about the catalyst. What it does is it decreases the activation energy. So that already is just C. And increasing the temperature is all about the average kinetic energy of particles. So obviously if we increase that, then that will increase. So it will be C. 9. The table gives rate data for the reaction in a suitable solvent. Which statement is correct? Okay, so here we have to work out the order of each substance. So if we double this while this remains constant, this doubles, which indicates that that is first order. Then looking at the hydroxyl, I'm going to pick this. That doubles, and this stays the same. This also stays the same. Question 10. What are the units for the rate constant K in the expression? Okay, so the overall order is 3. We have x to the power of 2 and y to the power of 1. The way I did this is I simply memorized all the different orders and their units. If you can find a different way, then that's up to you. But I basically made a table like this and just wrote it and rewrote it over and over and over again, and tried to identify patterns. So as you can see here, you're just decreasing by 1. Because if you think about it, this here is 1, this is 0, which is why we don't have moles. And then it just goes in decreasing order as you increase the order. Then for the decimeters, again, that's -3. This would be 0 because we're increasing by 3 every time. And then the seconds always stay the same, -1. So if you can find your own pattern or think of a way to do it, then you're able to write it out in the exam really quickly and then identify which one it is. So then that would mean 10 is D. Question 11. Which is the first step in the CFC catalyzed destruction of ozone in UV light? Okay, so CFC stands for chlorofluorocarbon. So that's a molecule that contains carbon, chlorine, and fluorine. Ozone molecules are very easily destroyed by free radicals. And they are present, these free radicals, they're present in the stratosphere as nitrogen oxides, or they're produced when these CFCs are broken down by UV light. So we're given here an example of a CFC. This is a very stable compound, but it is broken down by absorbing UV radiation in the upper atmosphere. Now, the bond that breaks is the CCl, the carbon-chlorine, because that's weaker than a carbon-fluorine bond. So it undergoes homolytic fission more readily. So then the chlorine free radical is released in this process and can then take part in a chain reaction, which uses up ozone and regenerates chlorine free radicals to react with more ozone and so on. So because we're breaking the CCl bond, again, we're going to get a chlorine radical, which means this can only be B. What ends up happening to that chlorine radical is So as you can see, we have that chlorine radical regenerated. You may be asked in other paper 2 questions to write out the steps for the catalysis of ozone depletion, and that's either for chlorofluorocarbons, but also for nitrogen oxides. So make sure you memorize these and you know what's happening. Also note that all reactions occur in the gaseous phase. Question 12. Which is true of an Arrhenius plot of ln K against 1 over T? So what we need to realize here is that we can substitute y equals mx plus c into the ln K equation. So I'm just going to write that out. So then, knowing this, the graph does not go through the origin. The activation energy can be determined from the gradient. It's not the gradient itself, but it can be determined from it. The intercept on the x-axis is the activation energy. No, it isn't. The intercept on the y-axis is the frequency factor A. No, it's actually ln A, so that's why D is incorrect. And that leaves us with B. So make sure that you can draw this graph and substitute y equals mx plus c into the equation. 13, which is correct about reaction mechanisms. A species that is zero order does not take part in the reaction. It does, it's just that its concentration doesn't influence the rate. And we can also show that graphically. Again, make sure that you know these graphs. So this is rate of reaction. If this is the concentration, what we'd get on the graph for a zero order reaction is a straight line. So it won't be A. A catalyst does not take part in the reaction. A catalyst does take part in the reaction, it's just not used up, and what it does is it provides an alternative pathway with a lower activation energy. So it's not B. Reactants in a fast step before the slow step are included in the rate expression. Yes, they are. Reactants in a fast step after the slow step are included in the rate expression. No, they're not. The rate equation contains concentrations of reactants involved up to and including the rate determining step, so the slow step. 14. Which conditions must be met for a reaction to take place? Well, this is the simple collision theory. Reactants must collide with sufficient energy. Yes. Reactants collide with correct orientation. Yes. Reactants must be in the same state. No, that's not a requirement. The third thing, which usually comes first and people tend to forget, is that collisions must occur. So collisions must occur first, with sufficient energy second, with correct orientation third. So that leaves us with A for number 14. 15. Further reaction R to P, which letter represents the activation energy for the catalyzed reverse reaction? Okay. So we're looking from P to R, and we're looking for the activation energy. This is the point that we have to get up to, and this is where we begin, so it will be C. That would be for the catalyzed reaction. For the uncatalyzed reaction, we'd go all the way up to B, so then it would be D. B would be the activation energy for for the forward reaction from R to here, uncatalyzed, and A would be, again, the forward reaction, but catalyzed for the activation energy. 16. Graph 1 shows a plot of volume of CO2 against time for the reaction of calcium carbonate with 1 mole per decimeter cubed of hydrogen chloride. With 1 mole per decimeter cubed of hydrochloric acid. The acid is the limiting reagent, entirely covering the lumps of calcium carbonate. So that is all graph 1. And we're looking to see what could give us graph 2. We're ending up with the same volume overall of CO2. It's just that it's a much quicker reaction. So for that to happen, we'd need a higher concentration of HCl, which we don't have. So it will have to stay as 1. And we'd need a larger surface area, which happens by breaking down a substance. So we need smaller lumps. So then that would leave us with C. 17. Which experimental methods could be used to observe the progress of the following reaction? Changing color. Whenever there's iodine involved, you can measure a change of color. Change in mass. There aren't really any solids. There's no way to measure that. But we can measure the third one, the change in electrical conductivity, because we have lots of ions involved. So that will be 1 and 3, which is B. 18. The data shows the effect of changing reactant concentrations on the rate of the following reaction at 25 degrees Celsius. Which is correct for the order of reaction with respect to fluorine and the overall order of reaction? Well, let's try and find a change in concentration of fluorine where ClO2 stays the same. So that would be this here, increases by 1.5, whereas this stays the same. So when fluorine increases by 1.5, the initial rate of reaction also increases by 1.5, which makes fluorine first order. Then looking at ClO in order to work out the overall order of reaction. We have a threefold increase where this stays the same. So we're increasing ClO2 concentration by 3, and the initial rate of reaction also increases by 3. So that would make ClO2 another first order. So the overall order is 2, with fluorine being 1. So that will be D. 19. Which statement describes the characteristics of a transition state relative to the potential energy of the reactants and products? It is an unstable species with lower potential energy. No, it actually has higher potential energy. So, well, that will be B. 20. Which pair of graphs represents the same order of reaction? So again, this just relies on you having memorized the 6 graphs. So which one matches up? C. So that will be 0th order. 21. Decomposition of hydrogen peroxide in an aqueous solution proceeds as follows. The rate expression for the reaction was found to be, which graph is consistent with the given rate expression? We're being told that this is a first order. So just using the graphs that we've already drawn, it will be, can't be that one, that's second order. This is 0th order. This is again 0th order. So it will be D. That will be first order. I understand that it might be tricky to know whether this is that one or this one, but they all make it very clear. They'll either have only one or make it plenty clear that one is first order, one is second order, with a very steep gradient for the second order. 22. Which of the terms in the Arrhenius equation takes into account the orientation of molecules? Well, that is A. A is the frequency factor. It's also called sometimes the pre-exponential factor. It takes into account the frequency of collisions and orientation of collisions. 23. Which variable is best to use when determining the rate of decomposition of hydrogen peroxide? Well, we're giving off a gas, so that should point us towards volume of gas released. There's no ions present, so it can't be conductivity. There's no hydrogen ions or hydroxide ions, so no pH. Volume of solution, not really, since we have this gas, the easiest way to do it, the best way to do it, because that's what they say, the best variable to use is not the volume of solution, but the volume of gas. Question 24. Nitrogen gas reacts with hydrogen gas according to the following equation. Why is the rate of reaction slow at room temperature? If the reaction is slow, it means that the activation energy must be high because we're not reaching that. It's taking us a long time to reach the activation energy because particles have less kinetic energy, they collide less frequently, so then we'll have a lower proportion of the ones that do collide, already a low number, to collide successfully with the correct orientation. So it must be A. The activation energy of the forward reaction is high, and that's why it's slow at room temperature. 25. Which is a correct unit for expressing the rate of a reaction? Well, I've just copied our table here. It could be both A and D. A corresponds to a 0th order, D corresponds to a second order reaction. So either one of those will be fine, even though the answers do say A is correct, the correct answer. 26. 100 centimeters cubed of a 1 mole per decimeter cubed solution of hydrochloric acid is added to 2 grams of small pieces of calcium carbonate at 20 degrees C. The volume of carbon dioxide produced against time is plotted to give curve P. Which change will produce curve Q, given that calcium carbonate is always the limiting reagent? Increasing the volume of the hydrochloric acid, that won't help speed up the reaction. That's the difference with Q. The reaction is faster, steeper gradient, so A won't have an effect, the desired effect. B, increasing the mass of calcium carbonate, well, that will slow it down because there's more of, because there's a larger surface area for the hydrochloric acid to cover. Increasing the concentration of the hydrochloric acid to 2 mole per decimeter cube, yeah, that would speed up the reaction. C. D. Replacing the 2 grams of small pieces of calcium carbonate with 2 grams of larger pieces of calcium carbonate. Well, again, we know that the larger the surface area, the faster the reactions. So increasing the size of the pieces won't help us in this case. It won't speed up the reaction. So 26C. 27. Which statement about a first order reaction is correct? So just reminding you of the graphs for first order reactions. A, the reactant concentration decreases linearly with time. Well, we can see that doesn't happen. It decreases exponentially with time, which means our answer would be B. The rate of reaction remains constant. No, that would be 0th order. The rate of reaction increases exponentially. Well, that would be 2nd order. 28. Consider the rate expression. Which change decreases the value of the rate constant? The rate constant is only affected by temperature, which means that to be decreasing its value, we must be decreasing the temperature of the reaction. 29. What are the units of the rate constant for a 0-order reaction? Again, in this case, I would just be quickly writing out my table, filling out my patterns, making sure they all make sense, and coming out with D as the answer. 30. The hydrolysis of tertiary bromoalkanes with a warm dilute aqueous sodium hydroxide solution proceeds by a two-step SN1 mechanism. Which description of this reaction is consistent with the above information? Right, so if it's SN1, it must be a unimolecular reaction, so we will only have one molecule in the rate expression, which means we can eliminate C and D. If we only want the bromoalkane, it means we don't want to be going through this step because this is what gets us the hydroxyl. So this must be the slow step in order for that to happen. The rate equation contains anything involved up to and including the rate determining step. So if this slow step is the rate determining step, nothing after it will count, which means our answer will be B. 31. Consider the following reaction between hydrogen peroxide, hydrogen ions, and iodide ions. Which changes could be used to investigate the rate of this reaction? Electrical conductivity. Yes, we have ions. Mass of solution. No, not really. Color intensity. There's iodine in there. Whenever there's iodine, you can measure a color change, or in this case, color intensity. 1 and 3, that would be B. 32, which quantity can be changed by the use of a catalyst? Oh, okay. So catalysts affect activation energy. So here they're trying to get you to think about both the forward and the reverse reaction. For the forward, the activation energy will be here, and for the reverse, it will be this one. So that gives us B. Why does the rate of reaction increase when the temperature is increased? The activation energy decreases. No, the activation energy is all about the catalyst, not the temperature. There are more particles with energy equal to or greater than the activation energy. Yes. Temperature is all about the average kinetic energy of molecules. The frequency of collisions between particles increases. Why, yes. If they have more energy, they collide more frequently. So that will be C. 34. The diagram represents the Maxwell-Boltzmann energy distribution curve of the reactants for a chemical reaction with different activation energies. What is the reason why the rate of the reaction with activation energy 2 is greater? Well, if we're fiddling about with the activation energy, it must be to do with catalysts. And if we require less energy for a reaction to occur, because as you can see, the second activation energy is less energy, it means a catalyst must have been added. C. Which change increases the rate of a chemical reaction? Increasing the size of solid reactant particles? No. We're trying to decrease the size in order to increase the surface area. Decreasing the concentration of aqueous reactants? No, we would need to be increasing the concentration to increase the rate. Increasing the surface area of a solid reactant? Yeah, that sounds like a good idea. 36. Which is not affected by an increase in temperature? The rate of reaction is affected. The collision frequency is affected. It's the collision geometry, so that's all about the successful orientation. That won't have anything to do with the temperature. 37. Consider the following reaction between nitrogen monoxide and oxygen. The reaction occurs in 2 steps. What is the rate expression for this reaction? Okay. Well, we're taking both of these into consideration because the slow step is coming last. So again, the rate equation will contain everything up to and including the rate determining step. So what we'll have is C. We have these two here and this oxygen. Although I have seen in some exam questions that instead of squaring this, they will just use the product because that's then repeated here. So instead of that, it will be same thing. 38. What happens to the rate constant K and the activation energy as the temperature of a chemical reaction is increased? Well, the activation energy remains unchanged, and the value of K will increase as temperature increases. So that will be D. If you want to keep a note of this, so increase in temperature, increase in K, increase in activation energy, decrease in K. Those are 2 relationships that you need to know. (39) X and Y react according to that equation. The reaction can be described by the following mechanism. What is the order of the reaction with respect to X and Y? So first, to work out the orders, we need to think about the rate equation. Since the fast step occurs after the slow step, we won't be including Y in our rate equation, which means Y does take part in the reaction, but is 0th order. So Y is 0. And X must be 2nd order. C. 40. The rate constant for a reaction is determined at different temperatures. which represents the relationship between the rate constant and temperature in Kelvin. This will be C. As the temperature increases, the rate constant K increases, and that's exponentially. So I mentioned that earlier, but I didn't say it's exponential. That's a good one to add to your notes. Which combination shows 41? Which combination shows a second order rate expression with the correct rate constant units? So that's second order. That's also second order because we're told the iodine is 0. And that just leaves us with the units, which will be D. Which pair of graphs shows a decomposition reaction of X that obeys first order kinetics? If you memorize the graphs, then these questions will be very easy. This will be C. 43. Which statements explain why a catalyst is used in the contact process shown below? A catalyst lowers the activation energy. Yes, it does. A catalyst moves the position of equilibrium towards the product. No. A catalyst allows the same rate to be achieved at a lower temperature. It does. So that will be B, 43B. "44. Which factors can increase the rate of a chemical reaction? Increasing the pressure, yeah. Increasing the temperature, yes. Increasing the particle size, no, because then we'd be decreasing the surface area. So that leaves us with A. 45. The diagram below shows the energy changes for a reaction with and without a catalyst. Which symbols represent the activation energy and the enthalpy change for the reaction with a catalyst? So the activation energy with a catalyst will be this one, from here to there, X. The enthalpy change will be Z because we're looking at this change, and that's A. Which graph is best representing the relationship between the average kinetic energy of molecules of a gas and temperature in Kelvin? Well, temperature is all about the average kinetic energy. So if temperature is increasing, the average kinetic energy of those molecules will also be increasing linearly. D. Which statement best describes and explains the effect of a catalyst on the rate of a chemical reaction? The rate increases because the frequency of collisions between particles increases. No. The rate increases because more colliding particles have the energy needed to react. Yes. They have equal or greater energy than the activation energy. 48. Which statements explain the increase in the rate of a reaction when the temperature is increased? More particles have energy greater than the activation energy. Yes. The frequency of collisions increases. Yeah, so that's an effect of the first one. The activation energy decreases. No. So that will be A. Again, the activation energy is all about the catalyst, not temperature. 49. Consider the following reaction mechanism. Which statement correctly identifies the rate determining step and the explanation? Well, it will be step 1 because it's the slow step. That's the rate determining step. Step 1 because, just because it's the first step, it doesn't mean that's the rate determining one. It's step 1 because it's the slowest step, B. 50. The following experimental rate data were obtained for a reaction carried out at temperature T. What are the orders? When we double this, this stays the same. This more than doubles, which means it'll be second order with respect to A. Then with respect to B, when this doubles, this stays the same, this stays the same. So it must be 0th order, which means it's C. (51) Consider the following proposed two-step reaction mechanism at temperature T. Which statements are correct? So all you have to do here is cancel items that are found on both sides. So we're cancelling this, also one of these. And if you take what remains, you will get that. 2, step 1 is the rate determining step. Yeah, it's the slow step. The rate expression for step 1 is, yeah, that's right. We've got 2 NO2s. So that will be D. All of them are correct. Very rarely happens to get all of them. 53. Which graph best represents a second order reaction? And they all have the same axes. So that will be B. Now here you can see a clear difference of the gradients between what would be first order here and what is second order there. Of course, this is 0 and this should be labeled with rate and would be a first order reaction.